In giving feedback on the Polynomials draft investigation, some of the common areas for improvement is, first of all, it's an investigation. You've got to know what you're investigating, and so when you report on the investigation, you need to begin with an introduction. So that's the first thing. People need to begin with an introduction that clearly identifies the focus. And really, you've just got to go back and read what the task is and put it into your own words. So if you open up your investigation document, because you'll need to refer to it, in Part A, the task is to look at a polynomial of degree 4. So you're investigating a polynomial whose maximum degree is 4, and it can be written in this form. And it's important that A, B, C, D and E are real numbers, and the restriction is that A cannot be equal to 0. Well, you need to identify that if A equals 0, then the term ax to the power 4 would disappear, and it would no longer be a degree 4 function. That would be 0, it would be a degree 3 function. So in your introduction, you've just got to clarify that you're talking about a degree 4 function and a degree 4 function can be factorised. Now, if you looked at the recording that Andy shared, he goes through all the different forms of polynomials. So they can have all 4 factors that linear. You can have a factor that is a repeat factor, so something like x minus 2 squared is a repeat factor and it just touches the x-axis. You can have a quadratic factor in the form ax squared plus bx plus c, and in particular that quadratic factor cannot be put into 2 linear factors. So that's where they talk later on about complex conjugate roots. All right, so the aim is to see if there is a relationship between the degree of a polynomial and its shape as determined by the number of turning points and the number of inflection points. So really, you're just putting into your own words what the task is that you're investigating. So to begin with, you're going to look at a degree 4, and then you're going to see if you can generalise to more polynomials of higher degrees, and then you're going to look at the different ways that polynomial can be factorised. So once you've done an introduction, then the next paragraph you need to talk about the polynomial you choose and why you chose it. So as you fill in this table, before you fill in the table, you've identified what you're looking for. So you've deliberately chosen a polynomial with 3 linear factors, and you're looking for the number of turning points, which is the number of maximum and minimum are turning points. So if you've got your polynomial that you've perhaps drawn in Desmos or maybe on your graphics calculator, then you actually need, and taking a picture of it, actually mark on your maximum and your minimum so that it's clear that you can see that there are 3 turning points because you've drawn them. So I've just drawn in, and you could actually say minimum here, maximum up here, my purple cross, and minimum over here. And you can see that there are 3 turning points. Now an inflection is where your polynomial changes shape. So in black I've got highlighted the convex part, and then there's a point at which it changes from being convex to being concave. So the curve is opening downwards for concave. So that point there is an inflection point. So I'll change my colour. And here in orange is where the shape changes. That's an inflection. So again, if you label your inflection points, it's very clear how your graph is supporting the table. So every time it changes shape, so it only changes shape from convex to concave and then concave back to convex, that only happens in 2 points. On this 4-degree polynomial. So there are 2 inflections. So once you've done part A, it leads you into a conjecture. So looking at part A, looking at your own investigation, you've got to point 3 of part A, present a possible conjecture in regard to the number of turning points and points of inflection. So some people have very clearly written a conjecture in regard to the number of turning points, and they've generalised. So in particular you looked at a polynomial of degree 4, but your conjecture you need to do in general for n degree. So with the 4 degree you might have seen that there were 3 turns. And so you might say, well, that's 1 less than the degree. So then you might generalise. So for an n degree polynomial, under the condition of linear factors, all right, all linear factors, it seems that there are n minus 1 turning points, and the conjecture must include the number of something to do with the pattern with inflection. So what I've noticed is people have only addressed half of the conjecture. In part B, you've made your conjecture, and because of that, and that conjecture was centred around a polynomial of form linear factors. Now you're thinking, well, is it true for polynomials of other forms? So that needs to be a link between part A and B. You need to explain that you're now going to consider polynomials still of degree 4 and see if having non-linear factors, so like a repeat factor, which is called a squared real linear factor, and 2 distinct. So here we go. If you look here at the general form, see that x minus alpha all squared, that's the repeat factor. So there are 3 distinct linear factors because the 4th factor is a repeat. X minus alpha times x minus alpha is a repeat. So you fill in another table and make sure that you've got a repeat factor. You might have a repeat factor with a negative, like you might have a repeat factor that is written in the second half of your polynomial. Like when you choose your example polynomials, you might have a reason for choosing different ones. You need to explain that. So people who have just shown working with no explanation, the reader isn't the one that has to work out what you're doing and why. You've got to tell the reader why you're choosing things and what you're trying to check out. And then when you've done that investigating, you need to refer back to your conjecture and say, my conjecture appears to hold or it appears not to hold. Or maybe the first part of your conjecture holds and the second part doesn't. Okay, so you need to connect part B with what you found out in part A. So B part 2, extend the investigation to polynomials of degree 5 and beyond. with only one squared real linear factor. See if your conjecture holds, and maybe you need to write a modified conjecture. And remember, the conjecture is in general. You can say, in particular, it seems to be supported with polynomial of degree 5 with the repeat root, but you haven't tested every form yet. So then you might want to do a factor that has been repeated 3 times, so and see what happens there. So you can see that part B in this person's work, there's no writing. There's very, very neat and very clear tables of information, and there's a real logical build-up of what polynomials were selected, but it's the explaining that makes the investigation, the analysis. So this function here, it's 2 lots of x minus 1 squared. So x minus 1 is a repeat root. So when the roots are used, I think it's worth saying that 1 is the repeat root and then 2 and 3 are the other distinct roots. This student has used, I'm anticipating that it was Desmos graphing software, so that needs to be referenced. So acknowledge the use of that software, or if you used a different package like GeoGebra or something like that. If you did a little bit of research and you found out some information, maybe you don't know what a complex conjugate root was, maybe you do research, and so again you might define what it is in your explanation and reference it, and then it'll be part of a bibliography. So part A and B and C are to help you to have a logical progression and with the way you investigate polynomials of the different forms and of the different degrees. So make sure that you connect the pattern of development with your conjecture, and when you make your conclusion, often it's easiest to rewrite the conjecture. So the final conjecture that you formulate, mention it in its final form, mention what evidence you have that it is supported, and mention limitations of it. So you might say that if the number of factors that are repeated equals the degree of the polynomial, all right, so let's say you've got a polynomial degree 4 and it's x minus 4 to the power 4, so it's got a single factor that is repeated the 4 times, that your conjecture doesn't work. But if it's anything less than that, maybe the number of turning points section of the conjecture is held, but the number of inflections isn't. So you may even end up saying, I need to form 2 conjectures under different conditions. I wonder if you noticed at the very end this reminder on the format of a report. I really hope that you have seen this, and I hope that the comments I've made so far, so the introduction is the outline, you keep explaining the method of why you've chosen your polynomials and what you're trying to identify, that, so that's the solution, and it's also the strategy in the way that you choose the different polynomials, the pattern. All right, most people are filling in the table really well, but maybe if I identified the key turning points and inflection points, that would help highlighting the relevant data. Then after each section there'll be conclusions that are drawn that are limited or appropriate to the form of the polynomial you're discussing. So that's what this dot point is referring to, and refer to your polynomials that represent those particular conditions. Make sure that you interpret the results and considering the reasonableness. So quite often you'll be interpreting the results having only looked at 3 examples at a single degree, or maybe you've only looked at degree 4 and 5 and you've tried to make a generalisation. So that will be the limitation of your results. All right, so really this top point's no different much to the earlier ones, except that it's in reference to your final conclusion. Remember that a bibliography is on a new page, and really you would only add something into your bibliography that you've referred to during your investigation. So make sure if you've made some comments that are based on things that you've researched, that you reference the ideas. And the same with your images. If you've got images to support, you've got to say where they've come from.